Okay, folks, today's tutorial is on ions and ionic bonds. And if you remember from the last tutorial when we talked about atoms, we talked about the structure of atoms and the number of protons and neutrons and electrons and how you figure out how many of each of those things there are in an atom. Today we're really interested in the electrons, and we're interested in the electrons in the valence shell because, as we said before, those electrons are the ones that are going to tell us something about the properties of that atom and how it can form bonds with other atoms. Well, if we look at our periodic table of the elements, just as a reminder, you know that the number here above the symbol, so I'm on hydrogen, that's the atomic number, and that's the number of protons. In a neutral atom, you would have the same number of electrons as the number of protons. An ion, however, is not neutral. An ion has either a positive or a negative charge. There are actually two kinds of ions. Ones that have lost electrons, which means they would have a positive charge, because if you lose a negative item, you'll have more protons than electrons, and so you'll be positively charged. Another kind of ion is negatively charged. Those atoms have gained electrons. Why would an atom gain or lose electrons? Well, let's think about the valence shell. If we remember, the valence shell was the outside shell of electrons. If that shell is not complete, the atom is not stable. And it needs to do something to become stable. We talked about covalent bonds in lecture, but we haven't talked about these ionic bonds. Let's take a look at an example, because it'll be easier to show you with a picture. I want to look at sodium. We looked at sodium one other time, and we can see that it has an atomic number of 11. That means it has 11 protons, and in the neutral state would have 11 electrons. Let's take a peek at that. At what sodium is going to look like. So if we put our 11 protons in here and we put our neutrons in here, we're not so worried about these right now. We want to put our 11 electrons in these shells. If you remember, 2 electrons go in the first shell. 8 electrons can go in this shell, so that's a total of 10. And there's one lonely electron out here. Well, there aren't enough electrons in the valence shell for sodium to share. It would need to share 7 electrons. But nobody's going to give up 7 electrons if they only get 1 to share from sodium. So what happens in cases like this, where there are very few electrons in the valence shell, the atom actually loses the electron. It goes off into space. And we'll see one of the places it can go in a minute. But it leaves. And when it leaves an atom with a complete valence shell, because this shell now is valence. It's a valence shell because it's the last shell out that has electrons in it. There aren't any electrons in this other shell here. None. So it really doesn't even exist, even though I showed it. Now we have 11 protons in the nucleus, but only 10 electrons. So there's a net positive charge. So we write that Na+. So this is the sodium ion. And we call positively charged ions cations. It's very simple. Now this ion is a very stable force, or a very stable atom. The other kind of ion is called an anion. In this case, well, let's take chlorine. Let's go back to our periodic chart just so we can see where we're at. If you go way over here on the right to chlorine, you'll see that it has an atomic number of 17. So that's the 17 protons. And if we now draw our picture, we'll put our 17 protons in the center along with the neutrons. And we're going to put 17 electrons out here. Well, again, we put 2 in the first shell. We put 8 in the next shell, so that's 10. And that leaves 7 electrons in the valence shell. It only needs one more electron. Only one more. And so if it can find an electron, if it can just pick that electron up out of the thin air, so to speak, if floating around in space, it will grab that electron. Now, it's got 18 electrons, but only 17 protons. So there's a net negative charge. This kind of ion is called an anion. So we have two kinds of ions. Cations that had very few electrons in the outer shell. Those lose their electrons. And where do those electrons go? They get picked up by an atom that only needs 1 or 2 electrons, in this case 1, and that atom becomes an anion. Cations and anions attract each other. A positive cation is going to be attracted to a negative anion. Check it out. This positive cation, sodium, has an attraction for this negative anion, chlorine. So that attraction holds these two atoms together. That attraction is called an ionic bond. The ionic bond, notice, is not a sharing of electrons. There's no electrons zooming around both nuclei like there were in the covalent bonds. Nothing shared here. The only thing holding these together is the attraction between a positive and negative force. Even so, this is a fairly stable bond. You think about table salt, that's sodium chloride, the stuff you just, sprinkled on your potato chips, or was sprinkled on your potato chips, or you put on your French fries, or wherever you put your salt. This is, you don't put in sodium and chloride separate, they're together in your table salt. And you can't separate them very easily. So this is fairly stable, but not quite as strong as a covalent bond. So now we know about ions, and we know about ionic bonds. Let me just show you some things that I think are important for you to remember. Our definition of an ion is an atom that has gained or lost an electron. And that means you're going to have two kinds of ions, ones that have gained electrons and ones that have lost electrons. The ones that have lost electrons are positively charged and called a cation. The ones that have gained an electron, one or more electrons, those are negatively charged and called an anion. Whenever you have negative and positives around, you're going to have an attraction, and that attraction is an ionic bond. Hope that makes things clear for you.